Imagine one day morning you woke up and found the clock is ticking so fast and you are getting aged so soon. Will you be scared? Or the clock is ticking so slow and you are getting bored in a classroom. Would you like to imagine such a nightmare? If the answer is no, then let's understand how to tick your clock in the right speed. Are you ready? Welcome to the second episode where we are going to learn how to measure the motor speed to ensure the clock is really ticking in the right speed. Let's start. Hello friends, welcome to the second video. In this video we are going to learn how to find out the exact RPM of this motor. This is the Blix motor. This is the motor given by Blix, and we already know the RPM supposed to be 60. It should be 60 RPM means 60 rotation per minute. In 1 minute, how many times the motor rotates, that is the measurement. How can you measure it? But now even more, the bigger question is, why should we measure if we know that it's 60 RPM from the Blix? Then why should we measure? So for that, let's see. I will connect it with one of the battery holder. It has 2 battery in it, and let's see. So just to see it properly, I will bring something bigger and fit into this. So now you can see it better. Even to make it more better, let's make a mark here. We'll keep something here as a marker. They are in the same line. This arrow, both arrows are pointing to each other. Now I am spinning it with 2 battery. Now try to feel how fast it is, and let me stop it. Now I will try with 4 battery, a Blix container with 4 battery, and let's try. You see the speed, it's more fast. So which one is actually 60 RPM? With this battery, or with this battery, or something else? So that's the question we are going to answer. We are trying to find out, so that we don't get stumbled on a fast moving clock or a slow moving clock. Just now we saw what happened, right? So that's the agenda. Now we have 2 solutions for this. One is the manual way, just now you saw. We'll make it little more better, the manual solution for the kids. And number 2, we will have a robotics way of solution, which is going to be a RPM counting machine made by Blix Boffin. This is the one. So let's see one by one. First we'll talk about the manual way of measuring the RPM for kids. Let's start. So here is the arrangement. As I mentioned earlier, the motor is spinning so fast. In that case, better to reduce the speed of the gear, and then how much you reduced, you have to multiply. So it's like, let me show you. Actual RPM, imagine it's 60 RPM. Imagine it's the 60 RPM as they mentioned, and then we want to slow it down 3 times. So this is the 3 times gear ratio. We will be learning in the next video, so don't worry about it. Just take my word. This way we can slow down the gear to 3 times. So once we slow down, it will be 20 RPM. 60 by 3 equal to 20 RPM. So if we can measure it's really 20 RPM, we can multiply by 3 until the real gear or real motor is actually running in 60 RPM. So we have to do this multiplication extra, but that way we are able to observe it correctly. Suppose it's not 20, it is 10 RPM. Then what will be the final motor? It will be 10 into 3 means 30 RPM. So whatever is the reading, you have to multiply with 3. So now how I have arranged this. So this is the motor, and this motor I have directly connected with a smaller gear with 20 teeth, and then that I have connected with a 60 gear, and there is a arrow next to each other. So now if I switch it on, you can at least get some chance to count. So you switch on your stopwatch from your monitor, from your mobile, and then measure like this: 1, 2, 3, and so on. So that's the idea. Okay, so this is the manual way of measuring, but we will be mostly covering the robotics way of measuring. That's the thrilling part, right? So let's see how it happens. So before bringing the final project again, I want to show some theory or some planning. Let's do some planning. So this is the thing. This is our gear, whatever the gear we have connected. So it's going to be the same as per the gear. There will be a big gear connected with the motor, and there have to be some way to measure robotically. So how it is? It could be many different way. So imagine you have a sensor. It's like the laser security sensor. There is a laser light falling like this, and there is a light sensor like LDR sensor, on which the light will fall and he will tell, okay, I see a light 1. Or if there is a block, somebody suddenly cutting through this or walking through this, there will be no light and he will be seeing 0. So this 0 and 1, it's like whenever this gear is rotating, and suppose you have some obstruction hang with this, and then this obstruction every time will go in middle of these two in a way, like suppose it's up and down, or some kind of arrangement where it will not hit both these sensors, but it will pass through this. So it have to be like this, and it have to pass like this. Okay, so if I bring the gear, it could be something like this, something is hanging like this, and then you have the laser. I can show it like this. So you have the laser light here, and this is the LDR sensor, and see, it's blocking. The light is not falling on the LDR, so the LDR will get 0. And then once the LDR will get 1, means light is not falling, means LDR will be high resistivity. And then once the wheel rotates and the blockage is out, it will see the light and the resistivity will go down. So it will be 0 and 1. So it will be like, once it is out, it could be 0 or 1 as per your logic, and then once it takes a full rotation and come back again, it will see the 1. So it will be 0 0 0 0 0 0, and then suddenly for a moment it will be 1 1 1, little bit of ones, and then again it will be 0 0 0. So your work will be to count a cluster of 0. So what is this cluster of 0? So the data, if I plot in a graph, it will look like always 0 0 0 0, and suddenly there will be a stream of 1 1 1 1 1, and then again 0 0 0 0, again 1 1 1 1, like this. So this whole 1 you have to count only 1. It's a cluster of 1, because it is staying longer at this position, because it is thicker or it is spinning slower in middle. You have collected multiple samples. Because of many reasons, there will be multiple 1, not a single 1. Otherwise what will happen? There is nothing, and suddenly one spike of 1, and then one more spike. That is the ideal case. In that case, you don't have to care about this cluster thing, but it may not be the practical. In the practical world, it will be little different. So for that, let's imagine there will be multiple 1, and you will be counting all of them as a single cross. So this arrow just crossed once for the whole cluster. Similarly, this is for number 2. So you will be counting the cluster 1 2 3 as long as 60 seconds has passed. So that is one idea, doing it by optically. Now I will show the way I have done it, because optical things are easy. It could be easy, but you need two laser, one laser source and the other laser sensor. So you need actually one input and one output device to be connected. Instead, what if I can make it done by a single sensor, and if it is accurate enough, it will be good for me. So that's the idea, and then I went with a different way of measuring it. The final waveform is going to be the same, but the measurement, instead of this one being the light intensity and this being the time, which is now, instead of light intensity, it will be magnetic field intensity, magnetic field intensity. So the arrangement will be little bit different. So if I erase it, only this much, and then this is the arrow, and instead of sticking that cellotape like this, I am going to stick a bar magnet, or a very powerful neodymium magnet. So if I want to show you that what is exactly I have used, so this is the neodymium magnet I have used. This is the magnet, two piece of magnet. Is very powerful. I have stuck here, and this is the Hall sensor or magnetic sensor. So this sensor is going to sense this magnet. Whenever it passing close by, it is going to detect 1. So the magnetic sensor is sitting here, and it is trying to find out that high power neodymium magnet. Whenever it passes, it will give me a bar of a hit of 0, a cluster of 1, otherwise 0. So the same logic mathematically, but practically I am doing a different way. So this is the one I have used, and let's see the code, how I have maintained in the code, and the final output, how it comes. So let's go to the main part. So I will connect this with my computer now. Where is the cable? And light is on. And just to see it manually, I will bring it closer to the magnet and see the second light. That's the digital 0 or 1 that is glowing. So it indicates that it can detect for a moment. But I'll keep it little far so that it won't bang on it and damage itself, because I have only one sensor. I don't want to damage it. Somehow I got it, otherwise I would have to order it again. But yeah, this is good enough clearance is there, so that's enough for me. And now this motor down. So okay, let me show you how it is formed. So this is the motor connected, and the same manual way of doing, I have reduced the gear so that my PictoBlox or the block coding can measure it correctly, because the block coding has some limitation or slowness. It might miss 1 or 2 hit or 1 or 2 sample during that one. So this whole cluster of 1 could be missed entirely by the code and end up having less count. So I don't want that to happen. So yeah, that's why I have slowed it down. Yeah, so computer also have limitations like human. And this is the setup. With that, let me go to the PictoBlox. Okay, so I have connected the ESP Boffin with my computer, and how I did that, for that you can watch my other video. I will keep the link in the description. Okay, so given that it is connected and all the setup is ready, let's click on the green flag. So let's see. So we are expecting it to be 20, right? Okay, so with the ground sound, it indicated that it's done, and it is 28. So yeah, it is hitting a little bit. So it's 28 into 3. It's going to be 28 into 3. So definitely it's not 60. 30 into 3, 90 minus 6. So how much? 84. Yeah, so 84 rpm. So this one is coming to be 84 rpm, whereas the power source was neither of 2 battery or 4 battery. The power was from the USB cable coming from the computer. So now we found this is not that 60 rpm that we are looking for, but we are looking for 60 rpm because we have a nice mathematical advantage. We can see it in next upcoming video, not the immediate next, maybe the next to next. So yeah, for that we have to make some change. So what we will do is, we will not run it through USB power. We'll take this out from the motor, and then we will power it using, so this double battery container, we just power it up with this, and the code is written such a way that there will be no change in the code, just that the motor will not stop rotating, that's all. So with that, let me manually switch it on, but before that I have to switch on this first, and then this one. Okay, so 19, and I have noticed once the count got missed, so it is supposed to be 20, almost close. So yeah, that's what I was telling, that it will not be exactly accurate, or maybe our measurement is wrong, or maybe the motor is moving a little slower because of the battery power or something. So this much accuracy is enough for us. And now let's try to understand the code. Now let's pay attention to the project. So this project, I have made it modular way. So what is modular way? You have to write the code in a more readable way. The code will anyway work if you make it a long sequence of code, but readability will be a problem. So if you write a code and somebody don't understand what you have written, that's not a good coding practice, right? So because of that, I have created some functions, or I have taken out the extra details which you don't want to bother during the top level code walkthrough. So what is that? So here it is. First of all, I was trying to switch on the motor using the USB power, this digital pin number 32. Why pin number 32? If I show you the manual coming with the ESP32 Boffin and how I have connected the device. So you see, this is the magnetic sensor or Hall sensor, and Hall sensor is connected with the port number 7, and motor driver board was connected. I have removed now. Motor driver board was connected in port number 6. So port number 6 means, if you see, port number 6 is actually pin number 33 and 32. So 32 is for direction. I am not actually changing the speed of the motor. So 32 is the one, if I switch on and off or send low or high signal, it is going to control my motor. So pin number 32. So if I come back here now, pin number 32 I am setting high to switch on the motor, and finally once this repeat until block is stop equal to 1. So stop equal to 1 means 60 minutes has been passed, and then you have to stop it. So I stop the motor then, and then I play the ground sound by the Toby. So how I am managing that 1 minute timer, where it is exactly happening? So that is happening here. This is the timer given by PictoBlox, where by default I initialize all the variable. This is the initialize all variable separately, so that you don't want to see all these internal variables while understanding the concept. So this is the counter, setting is 0. All the analog digital readings I am setting it at 0. By the way, this analog signal I am not using, but I am displaying it here so that you can see how the magnetic flux is changing when the magnet is coming really close and then passing by. Okay, so coming back, so this is the timer, and this timer is in second. So I am checking if it is greater than 60, because we might miss that 68th second because of the as I told you, the block coding is little slow. Somehow we can miss the timing, so that should not be a problem for us. It will be plus minus little bit accurate. Okay, this is the way I am measuring the time, and then this is a block which is ensuring that whenever it is seeing the magnet for the first time, then only it will start the stopwatch. So that's important, right? When you see for the first time, you cannot start the stopwatch at any point of time. You have to find out a right time when you see for the first time and take that as a starting point, and then calculate how long it takes to return back to the same position. That's more easy, right? So for that, this is that ensure a good starting point. So what it is doing inside, ensure a good starting point is actually looking for when the magnetic sensor digital value comes 1. That is the indication, right? When you see, by default it is initialized to 0, and then when you rotate this, and at some point it will be 1. Once it is 1, then you start. So yeah, you have to keep collecting the data. So this is the collect sensor data. You'll be collecting the digital data and analog data within the loop, so what happens if you don't have it? It will be an infinite loop, right? The variable has been updated only once by this initialize variable, but this collect sensor data is the guy who is actually updating. so it have to be in the loop. Every time you are checking, you are updating the variable and then checking if it is 1 1 1. Once it is 1 for the first time, it immediately returns back with the counter value 1, because we have to count that value. And then we are setting the old value to the new value, so that if you don't do that, remember I mentioned there is a cluster of data, so there are so many 1 coming in a cluster. So if this method has already counted this as a 1, and once you go back from ensure good point to the main repeat until block, he will again count it for the second time and say I found one more time. So that should not happen. I should ignore all these other pulses until it goes to 0 and then come back. So it's called rising edge. So this is the raising edge of the signal, so it should be only triggered by the raising edge. Okay, so for that for that I have taken care here, like I have changed this old and new value. I have make both of them same. What is the logic? This is the logic by which I am actually making this a cluster. So when you read the first value and the second time, before you can read the second value, I have a old reading. The old reading will get up to date from the new reading of now. So what happening? This is the new reading, and at the very beginning old reading will point to nothing, -1 or 0 or something. And then when the new reading is switched to the second reading, the old reading will point to the new reading, I mean the previous new reading. So every time the old reading, suppose this is the sample, so when new reading is pointing to this, old reading is pointing to this, and then next time when new reading is pointing to this, old reading is pointing to this. So they both are moving back to back. So whenever I want to see that if the cluster is ended, I will check the old reading. If the old reading is back to 0 and he is 1, that is what resembles a new raising edge of a cluster. So hope you understand. If you don't understand, please don't hesitate to message me in WhatsApp or some other way. You can comment also, and I will explain you. So yeah, this is the raising edge logic. By using two variable pointer, you can find out how the waveforms are changing. Using one variable, it's not possible. If you have a way, let me know in the comment section. Okay, so yeah, that's all. And then connect it, so collect the sensor. So the same thing that you saw inside the ensure good starting point, same thing is here. And then it is just collecting the data like this, and then sense and count one rotation. So just now I explained the thing. This is the logic. So if you have two variable, one old variable and one new variable, and you see if one of them is pointing to 1 and the other one is pointing to 0, that means the previous value was 0 and the new value is 1. That means it's the raising edge of a cluster. So that's where you are actually changing the counter to 1, and this will keep happening, and every time don't forget to assign the new to the old. Otherwise this logic is not going to work, as you understand. So whenever this new guy is leaving the new value and switching to the old value, he is giving away his old value to this guy so that he can hold it. So that's how hand in hand they are carrying forward the value. Okay, so yeah, I think you understood. And now once that happens and finally it is coming out of the repeat until block, means 60 seconds has passed, it will stop the motor if you have the control. In the second case we didn't have the control because we was externally powering it up. So what will happen, it will just send that signal, but nobody is there to receive in the Boffin side. So it's not going to work until you connect with the motor board. And then finally the ground sound is telling you that the logic is over. So this is the way. And the same way you can now connect the other sensor, other motor, the 4 battery motor, and see how the counting is, and definitely will find it higher. And then actually we got the answer. So for our clock we have to use 2 battery setup, and that is the answer. So we are not going for this 4 battery. There might be many miss because it will move faster, and maybe this magnetic sensor or the Hall sensor will miss some of the samples. So in that case we have to again further slow down to 3 times by adding more gears, and that you can try if you want. Let me know if you want to try or need my help. So with that, I'm concluding this video, and our conclusion is we should go with the 2 battery setup. Thank you. We're seeing you in the next video. Bye.